right, so today is a really short video. It's continuing implicit differentiation, but a little trick that you can find when you are taking the second derivatives. So first off, here is an equation, 2x cubed minus 3y squared equals 7. You should be able to find dy dx using implicit differentiation. I would highly encourage you to pause the video and find dy dx on your own. Then together we'll do d squared y over dx squared. That's a second derivative. All right, give that a shot. Okay, here is the first derivative. Derivative of 2x cubed would be 6x squared minus derivative of 3y squared would be 6y times the derivative of the inside, dy dx, equals derivative of 7 is 0. All right, I wanted to find dy dx, so get dy dx by itself. Negative 6y dy dx would equal a negative 6x squared. I'm moving the 6x squared to the other side. Dividing, I'll have dy dx equals negative 6x squared over negative 6y, which we could simplify to just being x squared over y. All right, the second derivative. Second derivative is going to require just a little trick. You might want to try to do it on your own first just to see what happens. It's really not bad. I'm going to move this stuff though before I do that. Let's move it off to the side just so I have a little bit more room to work with. All right, we know dy dx is equal to x squared over y. So if I wanted to find the second derivative, you just take the derivative again. Derivative of dy dx is the second derivative. So d squared y dx squared equals, all right, that is a quotient. It's going to require the quotient rule, low d high, low is y, d high, derivative of x squared is 2x, minus high d low, high is x squared. Derivative of y is dy dx. All over low squared, so all over y squared. Now, this is where people get a little bit confused. They see this dy dx and they try to combine it with that and put them together, but those are two different things, right? This is dy dx, that's d squared y dx squared. This one over here is a second derivative. That one over there is a first derivative. And people look at that and say, well, I think I'm done, but it's kind of weird because that dy dx is there. It's pretty easy, actually. Dy dx is just an expression. Dy dx is x squared over y, right? Dy dx is the first derivative, which I already know. So if I wanted to find the second derivative and I get an expression like that with a dy dx in it, just change dy dx to whatever it happens to be for that particular equation. For this one, it's x squared over y. So here the second derivative is going to be that, which I'm going to rewrite as 2xy, minus x squared times dy dx, which in this case is x squared times x squared over y, all over y squared. And we could make that look a little bit nicer. I could, let's see, let's talk about making fractions look nicer. First off, I could rewrite that as x to the fourth over y. I'm just going to do that right there so I have room to work with. We typically don't like having a fraction within a fraction, so we can fix that by getting rid of that denominator. That's a y in the denominator, so I'm going to multiply everything in the numerator by y, everything in the denominator y, because multiplying by y over y is like multiplying by 1, so it doesn't change anything. When I multiply the numerator by y, we'll end up with, let's see where I can write here, 2xy squared, right? Multiplying times that, minus x to the fourth, and multiply times that, all over y squared times y, it's y to the third. There's my final answer. All right, so not too much different than before. Finding dy dx just requires a chain rule, remembering that the derivative of y is dy dx. And then if you find the second derivative, if you ever get a dy dx showing up, use what dy dx is equal to in order to substitute it in. That's the only thing different. Today's assignment is practicing more implicit differentiation, so just those problems. Some of them are going to ask you to find the second derivative, and some of them will have a dy dx show up in there that you got to substitute. Others of them are just going to be straight up finding implicit differentiation. Same thing you were doing yesterday.